So here's a quick one on solving multi-step equations where we're getting into a little more complicated stuff, where we might find it easier if we simplify each side first. And then we're going to actually deal with variables on both sides, what we did today in class. You can handle it. Sometimes you might need to simplify one side to make it easier, and simplifying might include distributing. It might include combining like terms on one or both sides. Or maybe you don't like the way it's written, so you rewrite it to make it easier to understand. And I'm going to give you examples for each of those. Oops. So here we have what looks like a complicated equation, but we're going to start by looking at making each side easy. 32 is already simple, but the right-hand side has some like terms that we can go ahead and put together. We know they're like terms because they have the same variable and the same power. That means they have the same exponent, so this is 3x to the first and 6x to the first. Same variable, same power. That means we can go ahead and put them together. We have 6x's, 3x's is 9x's. 9x minus 4 on that side and 32 on this side. So then once they're combined, we just have a simple two-step equation. And remember, we're always looking to start by getting the thing with a variable by itself. If you can't guess and check it easily, you're going to go ahead and use opposite operations. So we're going to go ahead and add 4 to go ahead and get our variable by itself. That cancels out. We get 36 equals 9x. 9 times some number is 36. That number is 4. But if you didn't know that off the top of your head, or if it was ending up to be a fractional number, you can always divide each side by 9. 36 divided by 9 is 4. And there's your solution. But we made it easier by combining like terms. So this equation, we're still looking for what the value of x is, and yes, you can guess and check it, but let's move toward using other skills as well. In this case, we can distribute. For those of you that like to think of a generic rectangle, we're going to set up just a 1 by 2 rectangle, because we only have a monomial times a binomial, binomial. So negative 3 times x here is negative 3x, and negative 3 times 7 is negative 21. So this distributed is negative 3x. And a lot of you don't like subtraction, so let's just write it as plus a negative 21, making it a little easier to see what's going on. So here, once again, you always want to get that by itself, which means you're going to start with this constant. And we want to get rid of a subtract 21, so we're going to go ahead and add 21 to both sides. And we're going to add that on both sides. And then we get a negative 3x equals 36. A lot of you can see what x has to be. It has to be a negative number because the negative times a negative is a positive. Then you know it's negative 12. Some of you can see that right away. But if you can't, you have a multiplication. And sometimes they're decimals, and you would know the answer if you were guessing and checking forever. If you know that it's a multiplication problem, you're just going to divide by that number, in this case by negative 3, and you're going to get negative 3, and you get x equals 3 goes into 36, 1, 2, and a positive divided by a negative is a negative, so x equals a negative 12. Now I can go back and check to make sure that that's right. You should never get an equation wrong, because you can always throw it back in. So here we get negative 12. Negative 12 plus 7 is negative 5, so this is negative 5. Negative 3 times negative 5 is 15. Sure enough, that's true. So I want to remind you, we distributed first. that was the first thing we did just to make it easier. There's other ways to start, but that's the easiest thing. So make it easy on yourself. Speaking of which, this may not bother some people, but this subtraction of the variable does bother some people. So you have permission to use what you know about algebra to go ahead and write it in a way that's easier. So subtracting 6x is the same thing as adding a negative 6x. So here I can just switch these two. And I'm like, okay, negative 6x plus 3 equals 3. Well, that's pretty much easier because then we're getting this by itself. I'm going to subtract 3 from both sides. And we're going to get negative 6x equals 0. This always confuses people. Think about what makes sense. Some number times negative 6 is 0. X has to be 0 on that one. If you did the division, negative 6 divided by negative 6 gives you the 1x that you want. And 0 divided by negative 6 is still going to be 0. Sometimes you're going to have variables on both sides. And in this case, we have something that needs to be simplified first. So let's go ahead and do that distribution once again. 3 times x minus 5, 3x minus 15. So we get 3x minus 15 is equal to 6x minus 3. Here's what you need to understand. You can choose, whoop, that's not going to work. You can choose any, well, let's see if I can get this down here. You can choose any first step with the goal that you're getting the variables on one side and the constants on the other. I like to try and make it so I don't end up with a negative number in front of the variable, a negative coefficient. Oh, by the way, constant, what's that? Constant is somewhere. The definition was somewhere on this page and now it's not there anymore. Anywho, so we have variables on both sides. And we're going to go ahead and you can start anywhere. So I, for some reason, like to start with my variables, and so I'm going to try and get all my variables on this side. So I'm going to get rid of this. So I'm going to subtract 3x on both sides. And I'm going to end up with, I'm going to move this dude out of the way. I'm going to add, this cancels out, and I'll end up with a negative 15 on this side. And a 3x minus 3. So then the variables are all by itself on one side. I want to get rid of this guy now. So I am going to go ahead and do the opposite. The opposite of subtract 3 is add 3. And we end up with 3x equals negative 12. Once again, you can look at this and go, well, x has to be negative 4 because 3 times negative 4 is negative 12. And if you don't know that, then you're going to divide by 3 on both sides to find out what it is. Okay. So we think x is negative 4. Let's check. Make sure we're right. So we're going to go ahead and plug negative 4 in. And see if we end up with the same thing on both sides, starting with our parentheses. We get 3 times negative 4 minus 5. Ugh, I hate that. Negative 4 plus negative 5, negative 9. 6 times negative 4 is negative 24 minus 3. Oh my god. 9 times 3 is negative 27. Negative 24 minus 3 is negative 27. X is negative 4. There you go. Nice work, humans. So, here we have what looks like an early equation, but I know you can handle it. We're going to look at taking it each side and simplifying it first, making it easier. In this case, we have some like terms on this side. This subtraction bothers you in front of the 3x, change it to adding an opposite or negative 3x. So now you can just say, okay, I got some like terms there. I've got a 6x and a negative 3x, and that simplifies to 3x. That didn't write very well. And then we have some constants here. I wanted to talk to you about that word. Constant is any number that has no variable attached to it. So because the 2 is always a 2, it's always constant, whereas the 6x could be 6 times 1 is 6, or 6 times 2 is 12, or 6 times 3 is 18. It can change. So the constants here are the 2 and the 8 and the 8. So I'm going to put these constants together. It'll make it easier for us to go ahead and solve our equation, because it'll be much easier to look at. And then on the other side, we have a visually way that a lot of people get frustrated or confused, and that's subtracting a negative. Subtracting a negative is the same thing as adding a positive, so you can think of that then as 8 plus 2x. Now, here we are with the idea that we can choose any step. Whoops, I'm going to get hold of that. I want to choose any step. Woo, how fun is this? I'll move that for a second. I want to choose any step that moves you toward getting that variable by itself. And here we can go, wait a second, I got 2 8s, one on each side. So if I take away an 8, then I'm going to end up with 3x equaling 2x. Is that possible? Think about that for a second. Can that actually happen? You're not sure? Well, then keep going with your process. We want all the variables on one side and all the constants. Wait a second, there are no constants left. So we're going to go ahead, we'll try it. Some of you have probably already figured out what's going on. I'm going to subtract 2x on both sides to get all the variables on the same side. And I'm going to get 1x equals, 0. That makes sense. Because if x was 0 here, and x was 0 here, we'd end up with 3 times 0 is 0 equals 0.